In part 2 of software systems, we discuss operating systems. Please take a moment to read the learning objectives for this video. The final type of system software is operating systems. An operating system or an OS is system software that acts as an interface between the user and the computer hardware. It provides common services for computer programs. An operating system is a go-between. It's an interface to the hardware. Users and application software talk to the OS. The OS talks to the hardware and other system software and manages the interactions between the applications and hardware. The operating system also informs the users of any system changes. The operating system is an interface between the application and hardware. The application communicates with the OS. In many ways, it has to tell the operating system what to do. Not how, but what. The applications do not need to know how to talk directly to the hardware. Instead, the application might tell the OS to write some data to the file system or send a message through the internet. The OS manages the memory, processors, devices, and file system. Operating systems manage the memory by keeping track of it. The OS knows which parts of the memory are used and by which applications, and what parts are free. When multiple programs are running, the OS decides which process will get memory, when, and how much. One way the OS manages the memory is allocating the memory when a program makes a request. The OS knows where that program is in the memory. Once the process exits, the OS deallocates the memory so it will be free for another program. Another job of the OS is to manage the processors, which are the CPUs. It keeps track of the processors and the status of all running applications. Just like with the memory management, the OS allocates a processor to a running application and deallocates the processor when the processor no longer needs it. The OS uses a device manager to keep track of all devices. The device manager decides which application gets the device, when, and for how much time. Just like with memory and process management, the OS allocates a device to a process and then deallocates the devices when the application no longer needs it. The operating system file manager keeps track of information, location, uses, status, and etc. on the storage device. In other words, the OS manages the file system. It decides who gets the resources, such as files, and for how long. When the resources are no longer needed, it cleans them up and removes them from the system. The operating system has other important activities, such as security, performance, and tracking jobs. It secures the system to prevent unauthorized access to programs and data. It monitors and controls system performance by tracking how long the delays are between request and execution. It also tracks how long applications have been using system resources, such as processor, disk, and memory usage. Other important activities are detecting errors and coordination between the software and users. The OS handles application crashes and provides debugging data to programmers. Operating systems are very busy, so it prevents collisions between different users and processes trying to use the same resources. There are many different types of operating systems, each designed for a particular purpose. The types we typically use are multitasking, multi-user, and multi-processing operating systems. An operating system might execute a single program at one time or multiple programs simultaneously. In a single tasking system, only one program can run at a time. The OS dedicates all of the hardware resources to that one application. A multitasking system will share the resources among many running processes. A single user OS only allows one user to use the interface at a time. The OS and resources are dedicated to that user. No other user can access the system. A multi-user OS shares the resources among all logged-in users. A multi-processing operating system has two or more processors that process different data at the same time. Since it happens at the same time, we call it parallel processing. One processor might be working with memory, while the other one is processing file input and output. Distributed operating systems distribute the processing power to many computers. This operation is similar to how a computer can have multiple processors. Instead of using processors on its own motherboard, it uses processors on other computers. Each computer processes the data as part of the larger processing network. Embedded operating systems are integrated in a chip on the device. These chips perform specific functions for the device. Most smart devices have an embedded OS. Examples of these devices are terminals, copy machines, cameras, washing machines, and TVs. In a real-time operating system, input and output operations are happening immediately without delay. RTOS are used in time-critical circumstances, such as with medical devices, scientific experiments, industrial systems, and transportation control systems. There are many operating systems, but most of them fall into three families, which are Windows, Macintosh, or Unix-like systems. Most people use Windows for desktop. Macintosh is primarily used for desktop and mobile devices. iPhone uses macOS, which is based on the Macintosh OS. Unix-like systems are used for server and mobile devices. Android uses Linux, which is the Unix-like system. In summary, an OS is system software that acts as an interface between the user and the computer hardware and provides common services for computer programs. An OS performs the primary system functions for managing memory, processors, devices, and the file system. There are various types of operating systems. Ones we discussed are single-tasking, multitasking, single-user, multi-user, multiprocessing, distributed, embedded, and real-time operating systems. The primary operating system families are Windows, Macintosh, and Unix-like.